In this video, we'll look at the Poisson probability distribution. The Poisson distribution is used to calculate arrival times or occurrences of instances like repairs needed, number of leaks in a pipeline, discrete items where you can't have half a leak, you can't have half of a repair needed. It has to be a discrete value, a whole number, integer value. As you can see from the formula here, we need 3 values to calculate the probability of a particular instance. We need lambda, which is the mean. We need x, the particular occurrence, 0, 1, 2, 3, 4. And we need e, which is the constant that we'll use Excel to calculate. If you do not have your workbook set up like this, why don't you pause the video, take a moment, enter these values. Don't worry about putting in this formula. I just put it here for us to use for this video. Once you get everything entered, we will solve the problem in the text, which talks about arrivals at a drive-in teller window of a bank during a 15-minute period on a weekday morning. And it makes the assumptions required to make this a Poisson distribution. And it says that the average arrival per 15-minute interval is 10. So we have in our model 10 cars on average arriving at the drive-in teller window per 15-minute interval. We'll enter 10 there as our lambda. We'll calculate E. In every instance in Excel, we will calculate E this way. It's the function exp, and the value we enter is 1 to the first power. Press enter, and that gives us E, and it calculates it out several decimals. It's important that you do it this way. You'll get different answers if you don't calculate it all the way out. Now let's use the formula to calculate the probability of a particular value of x, or the probability of a particular number of arrivals, and we'll just do 1 through 6 so we can fit them on. You could do 10, 20, whatever. So that requires 7 numbers. Here we'll start with 0, 1, 2. Here we go, 0 through 6. We'll use this formula here to calculate the probability of each value of x. I'll begin by solving for the numerator, which is lambda. And I'll make that absolute because I'm going to copy this. Raised to the x power, I'll leave that relative, so as I copy it down, it gets the correct value of x. I'll multiply that times e. Again, I'll make that absolute. And I'll raise that to the inverse of lambda, which I will also make absolute. That gives me my numerator. Now the denominator is x factorial. Use the factorial function in Excel fact. Point to x, leave that relative, and I have solved the value. I'll go on here and format that appropriately. The number format, I'll use the number format dialog box. I'm going to change that to number. I'm going to move it to about 6 places behind the decimal. That should be enough. Good. We have the probability of 0 arrivals. I'll double click on that, and that gives us the probability of 0, exactly 1, exactly 2 arrivals per 15-minute interval. Now, a lot of times using the Poisson distribution, we want to calculate the cumulative number of arrivals. In other words, the probability of 3 or less arrivals. So less than or equal to x. This is a discrete distribution, so equals has a meaning. It's possible to have exactly 0, unlike a continuous distribution, where the probability of exactly 1 is 0. So we'll go ahead and calculate that. For the 0 value, it's simply that value. We just go get it. For the remainder, we want to take the value above, kind of a running total, and add to it the new instance for that value of x. So in this way, we get the cumulative arrivals. Now that's the long way to do it. There is a faster way that is preferred because it's quicker and there is less likelihood of a mistake, but you need to understand the Excel function in order to do this. It's the Poisson.dist function, and it wants the value of x, which we'll leave relative, and the mean, or lambda, which is here, which we'll make absolute. And then it wants to know whether or not it's cumulative. And if we enter false, what we're telling it is, give us the probability mass function. In other words, give us the value of that x occurrence, which in this case is 0, the probability of 0. So I'll say false to the cumulative question, press enter, paste this format here using my format painter, click there, I double click, and you can see that these values match these values much quicker. Same way with cumulative, or less than or equal to x, we use the PoissonDistribution function. We provide a value for x, which is 0, that relative, a value for lambda, the mean, which is absolute, and then in this case we answer true to the cumulative question we do want. Cumulative values, press enter. We'll go ahead and use the format painter to quickly get that format. Double click, and you can see that this column of values matches this column of values. So I can say, what is the probability of 3 or fewer arrivals in the 15-minute period? The value is right here. This is how we solve for problems involving the Poisson distribution.